Good morning, Math 2 students. This is Mr. Flynn. These are the notes for April 23rd. So 4/23/20. I used this same sheet earlier the week. If you'll notice, that's all the factoring. Now, you should have this all filled out. I filled it out earlier, but I'm using a blank sheet because I'm coming down to the second side, and I've added some stuff to it. We're going to use the factoring that we learned up here to now solve for the x values. And so you're going to see it's actually going to be an equation. Okay, it's going to be an equation where it equals something. And right now, it's always going to equal 0 for us. Okay, so when we solve for the x values, what we're actually doing is finding the roots, the zeros, the solutions, or the x-intercepts. Remember, they're all the same. So what we're saying is, if we have this graph here, if we use our parabola, which is the quadratic, right? Quadratic. Wherever it crosses the x-axis, those are the solutions, the roots, the zeros. Well, those are our x values, okay? So those are our x values when y equals 0. So this over here is really the y. So when y is 0, here, that parabola crosses the x-axis somewhere, okay? And that's what we're going to be finding out. So we're not worried, right? I'm going to take some of this stuff out of here. We're not going to be worried that the parabola opens up, right? It opens upward or it goes downward, right? It opens up downward. But we are going to think about some things. The y-intercept, where it crosses the y-axis, that'll be coming up soon. You remember the dotted line? That's the axis of symmetry, right? Wherever that is, we're going to find out what that is coming up very soon. That point where the axis of symmetry goes through is called the vertex, right? That vertex, we're going to find it out pretty soon. Right now, we're going to use factoring to solve for x when the quadratic equals 0, because those are where the parabola crosses that x-axis, or that's where the y equals 0 and the parabola crosses the x-axis. So there's a lot of things we know about these parabolas, but we're going to come back to a lot of that later, and right now we're just going to practice solving, okay? So let me clean up some of this stuff here. So for right now, we're going to go back to this value here. Let's remember is always the y value, okay? It's that f of x, which is really the y value. But right now, that y value is 0. We're just going to give it a number. In the future, it's not going to be 0, and we're going to talk about how to get it to be 0. But we're not going to worry about that right now. We're just going to worry about trying to find this, okay? Find out what those x values are. And with a quadratic, there's a possibility of 2. Remember, if the parabola never crosses the x-intercept, the x-axis, you'll have no answers. There are no solutions. If it, let's say, comes and touches it just once, barely, you'll have one solution. Or it'll cross it both times and have 2 solutions. So we're going to look for the 2 possible solutions, and we're going to use our factoring. So let's look at this x squared plus 3x plus 2. If we remember our factoring of a trinomial, we're going to put a 1 in front, and that leading coefficient times the last term. 1 times 2 is 2, and now we list the factors of 2, 1 and 2. Then we have to remember that if the last term is positive, the signs are the same, right? We don't know if they're both positive or negative yet, because then we have to look at the middle term. So if the signs are the same and the middle term is positive, then they're both positive. So this is positive and this is positive. So this factors 2, and before we think about the factor, it's 0 equals, remember. And then we have x plus 1, we got from there, times x plus 2 we got from there, okay? So there's our work. We just factored it. Now we're going to use our factoring to solve, because if, let's say, I'll use a different color, this times this equals 0, then one of them, this one or this one, equals 0, Okay, so we're going to use that theory to solve. I erased way too much here. So we have x plus 1. So we're going to take this and set it equal to 0. And we're going to solve. Subtract 1, x equals negative 1. So if we were to take negative 1 and plug it in for both x values, the first one up here, negative 1 plus 1 would be 0, and this whole thing times the second part, 0 times whatever it is, will get you 0. So that's one possible solution. The other one is to take the second one and set it equal to 0 and solve. And we get x equals negative 2. So our possible answers are, and again, I'm going to do some erasing here, right? Our possible answers are negative 1 and negative 2. So what we're saying is right here and right here is where the parabola crosses the x-axis. When y is 0, notice that right here, that y is 0, we go over to negative 1, we go over to negative 2. That's where the parabola crosses. Does it cross like this? We don't know. If I were to erase all that and say, here's my x-intercept, here's my x-intercept, does it cross like this? We don't know yet. We'll find out those in the future, but right now we just want to find out what the x and y value is when it equals 0, so our x's equals negative 1, negative 2. Okay? We don't have to graph, but I use that as an example to show you. So on the second one, we're going to do it again. All I'm doing is giving you different factoring now. So remember that 1 times the 6 is 6. 1 and 6, 2 and 3 are the factors. So we know that the last term says that the signs are, that is negative, so the signs are different. And then this middle term tells us which one is larger. The larger one is negative. So let's give the negative signs to the larger ones, positive to the lower ones. And which two give me negative 5? Right here. So 0 equals x plus 1, x minus 6. Now, how do I solve? Take the first one, set it equal to 0 and solve. X equals negative 1. Take the second one, set it equal to 0, and solve. And we get x, oops, sorry about that. We get x equals 6. So in this case, if we were to graph, here is where one of the x-intercepts are, and it looks like the other one is actually off. So we don't know if the parabola goes this way or if it goes this way, right? We don't know that. We just know our answers are x equals negative 1 and 6. And we're done. And the third one, okay? Let's see what we have here. So again, we have our 1 here. 1 times 20 is 20. So we have 1 and 20. We have 2 and 10. We have 4 and 5. Those are our factors. The signs are different because the last one's negative, but the larger one is positive. So these are all positive, these are all negative. Which two, when added together, give you positive 8? Right here. So now, notice what we have here. We have f of x equals, but what we're going to do is we're going to call that 0 right at this point. Because the only way to solve for our x values is when y equals 0, right? Where it crosses the x-axis is when y is 0 here. So we're going to call this the f of x, which we know is y. We're going to call it 0. And that equals x minus 2 and x plus 10. And now you solve for your x's. How do you do that? Set the first one equal to 0 and solve. That's one answer. Set the other one equal to 0 and solve. So my two answers are x equals negative 10 and 2. Right? Not too hard. Again, I have the graph here. It would cross here at 2, and then the other one would cross way out over here, okay, somewhere. Now, I say don't forget special cases. I put it down here on accident, but I'll write it up here. So we have f of x equals x squared minus 36. This is a binomial, but it's a special case. And our special case of binomials is when we have a perfect square minus a perfect square, which is called a difference of squares. Now, with that said, let me get rid of some of this stuff here. All we have to do is take the f of x and make that 0, and then we're going to factor x, and remember, because the last term is negative, these have different signs, but it has no middle term, so the only two numbers when added together that cancel themselves out, but then multiply get you 36 is positive 6 and negative 6, because 6 squared equals 36, because 36 is a perfect square. So then, how do you solve for your x values? Take the first one, solve, x equals negative 6. Take the second one, solve. So we have x equals 6 and negative 6. So one of the few times you get an x is a 6 and its opposite, negative 6. Okay? So we have all of our factoring that we have to do that we've already done. You've practiced the last couple days, difference of squares, but now remember, we're solving. Look where it said solve for the roots, right? It was f of x, all right? Here, solve for x, it was equal to 0, all right? We have to remember those things. The last thing is simplifying radicals. Now, we did a little of this, but I'm going to show you quickly, all right? What you have to realize is that the square root and something, whatever it is, squared are opposites of each other. Just like if you were to do multiplication and division are opposites of each other. Addition and subtraction are opposites of each other. The multiplication can undo division, right? 36 divided by 4 is 9. So 9 times 4 equals 36, right? They go back and forth with those same numbers. The same thing happens with the radical. All right, this is called a square root. And this is a square. So what we're saying is, let me clean up some stuff and give me some room here. We're saying that the square root of a number, all right, and the square undo each other. They're opposites of each other. So what we're going to do is take the number on the inside of the square root, all right, and we're going to try to find pairs. Because what? 2 squared, which equals 4, 2 times 2 equals 4. The square root of 4 is 2. So the square root of 4 is 2 times 2 on the inside, and that equals 2. So we find pairs, and when you find a pair of numbers times each other inside the radical, you can get rid of the radical and just write the number, okay? I'll give you another quick example of that. So we just used the number 36, right? So 6 squared, which is 6 times 6, equals 36. The square root of 36 is really the square root of 6 times 6, and because we have a pair, we can pull it out and take the radical off. The square root of 36 equals 6, okay? So keeping that in mind, we have to take 20, and we're going to use what's called prime factorization. Prime factors. Okay, prime factors. So what we want to do is, remember when we listed the factors of 20 up here, we listed their pairs. But now what I want to do is take and factor out a prime, the lowest prime number. And do you know your prime numbers? Okay, a prime number is greater than 1, so it can't be 1, but it is a number that can only have 1 in itself as factors. So like 2 has 1 in itself as factors. 3 has 1 in itself in factors. 4 is not a prime factor because 4 has 1 in 4 and 2 and 2 as its factors. 5 is prime. 6 is not prime. 7 is prime. 8 is not prime. 9 is not prime. People think 9 is prime because it's odd, but remember 9 can be 1 and 9 and 3 and 3, so you can't have that. So we're going to use these numbers, and if you keep going, 10 is not prime, 11 is prime, and so on. We're going to factor this out, and you'll see a long multiplication problem. So underneath, this is 2 times 10. That's a prime number, so that's done. So, but 10 is not prime, so we need to factor it further. So the 2 comes down, times, and this becomes 2 times 5. So now, if you take 2 times 2 times 5, you'll get that 20, right? And they're all prime numbers. So this is really, the square root of 20 is really the square root of 2 times 2 times 5. And now we look for pairs to take out of the radical, and that's those. So that 2 times 2, which is 4, or the square root of 4 is 2, we can take that out. So we take a pair, and we take it out as one number, and what's left inside? That 5, so it stays inside. So this is a reduced radical of that. A lot of thought process there. But go on your calculator, take 2 times the square root of 5, check that number, and then take the square root of 20, you'll get the same answer, okay? They're the same things. And we have to learn how to reduce our radicals or simplify our radicals. So what are we going to do? We take the number 50. We do the prime factors. It's even, so 2 goes into there times 25, then 2, and 25 is 5 times 5. So we have this equals the square root of 2 times 5 times 5. Do you see any pairs? That pair can come out. So it comes to the front as one number times the square root of what's left inside, 2. 5 square roots of 2 that we call that. So if you do that in a calculator and that in a calculator, you'll get the exact same answers. So that's how you can check your work, okay? So now let's take 32. 32. That becomes 2 times 16. 16 is not prime, so that becomes 2 times 2 times 8. And that becomes 2 times 2 times 2 times 4. And that becomes 2 times 2 times 2 times 2 times 2. So we really have this in there. So really, that 32 is the square root of 2 times 2 times 2 times 2 times 2. So look for pairs. So 1 2 can come out, another pair, another 2 can come out, and that's left on the inside. And so we can do this now. 2 times 2 is 4, square roots of 2. There you go. Okay? So we're just looking for pairs and number. And remember, pairs and number you take out as one number. So 98, let's see what we get with 98. 98, prime factorization. It's even, so 2 goes into there. Let me see, that's 49 times. So 49 is not prime. If you know your multiplication tables, that becomes 7 times 7. So here's 2 times 7 times 7. So the square root of 98 becomes the square root of 2 times 7 times 7. As you can see, there's a pair. That 7 comes out as 1 7 times the square root of what's left inside. 7 square roots of 2. Okay? And I have, I think, just a couple more. The square root of 40. Okay, 40 becomes 2 times 20. 20 is not prime. 2 times 10. That 10 is not prime. 2 times 2 times 2 times 5. So this becomes 2 times 2 times 2 times 5. There's one pair. A 2 can come out. Now, there's only 1 2 and 1 5, so they both stay in, and we multiply it. 2 squared roots of 10. There's your answer. Okay? Last but not least, 72. 72, the prime factorization. It's even, so 2 goes into there. Looks like 36 times. And that becomes 2 times 2 times 18. 2 times 2 times 2 times 9. Notice my multiplications in my head. I'm doing pretty quick, and you're like, oh, where'd you get that number? Remember, this equals that number above it, okay? 9's not prime, as I talked about earlier. 2 times 2 times 2 times 3 times 3. All right, so this becomes the square root of 2 times 2 times 2 times 3 times 3. There's a pair, so a 2 comes out. There's a pair, so a 3 comes out. And that's left inside. We keep that, and this we multiply. 6 square roots of 2. So always take this number in your calculator and your answer in your calculator, see if you get the same answer. So that is simplifying radicals. So as a very quick review, I think we've done a lot of this a little in some way, shape, or form, but we're using factoring to solve. So these are going to be equal to 0. We don't have to graph, but I wanted you to know that when you solve, when the quadratic equals 0, that's when y equals 0. And when y equals 0, we can find the x-intercepts, okay? When you have it as f of x here, we take the f of x out and we make it 0, okay? And then we do the same thing. We factor and solve. And down here we have simplifying radicals, and that's using prime factorization to take the number inside the radical to write it out, looking for our pairs. Looking for our pairs. And a pair comes out as one number because the square root of, let's say, 25 is really the square root of 5 times 5, and the square root of 25 is 5, so that means the pair comes out as one number on the outside. Okay? Simple enough. Hope that helps. Watch this video, do the worksheet, turn that in today, and we'll talk later.